in this section of notes, we're still going to talk about three-dimensional figures. But we're going to talk about how we can create them or create two-dimensional figures from a 3D figure. So the first thing we're going to talk about are cross sections. And a cross section is a slice of a solid formed by the intersection of a solid and a plane. Meaning we're taking a plane and we're cutting a three-dimensional figure in half. Okay? And the 2D figure is what you create when you cut that figure in half. So it's like if you break your pencil in half cleanly and perfectly, and you look at where you broke, it should be a nice perfect circle, as long as you broke it perfectly. So if we take a look at these examples, we have this triangular prism in the first one. And we're going to determine the two-dimensional figure formed by each cross-section. Well, what I like to do, I trace on the three-dimensional figure where the plane is hitting it. So I'm just tracing on the outside, kind of along where the plane is hitting the 3D figure. And then I take a look at what I drew. I drew a triangle, so that's the cross-section. Okay, the plane is creating a triangle with that three-dimensional figure. So you just say triangle. That's the two-dimensional figure form. Okay. For B, again, I'm tracing along the three-dimensional figure where the plane is hitting it. Go back, and I'm kind of estimating what's over there. And I just trace around it. And I notice where I traced, the two-dimensional figure I made when I traced was a rectangle. So that is the 2D figure formed by that cross-section, a rectangle. If we take a look at the third one, again, I'm going to trace. So we have this cylinder. I trace along the outside of the cylinder, along the three-dimensional figure, along the plane, and I'm kind of estimating what's happening behind it. If we trace along the outside of that cylinder, along the plane, I get a circle. So the three-dimensional, and I kind of wrote circle weird, the three-dimensional figure formed, did it again. That C looks like an E. I'm sorry, this is a C. Okay. It's a circle. Another helpful way you can tell is if the plane is parallel to the base, how in A. The plane was parallel to the base, which was a triangle. That's what your cross-section is going to be. In C, the plane is parallel to the base, and the base of a cylinder is a circle. Well, that's what your cross-section is going to be. In B, the tracing method is probably what's going to work for best for B because the plane's going through the circle. So you kind of follow the outside and see what two-dimensional figure you get. Okay. If we take a look at D, again, I'm going to trace along the plane where it's hitting my 3D figure. I'm going to trace along there. The two-dimensional figure that I get, I drew a rectangle. So the cross-section is a rectangle. If we take a look at E, again, I'm going to trace along the outside of the sphere, along the base, or along the plane. Again, I'm estimating kind of what's happening behind it, but it's just going in a circle form. So I get a circle. I don't know why my C's put E sometimes. There, circle. And then in F, again, if we use that tracing method, I trace along where the plane is hitting the cone, and the 2D figure that I get when I trace is a circle. You can also use the method that the plane is parallel to the base of the cone, and the base of a cone is a circle. The next thing we're going to talk about is taking a 2D figure and creating a 3D figure. Okay? You can take a two-dimensional figure and rotate it about an axis or a line to form a three-dimensional figure. So for example, take this rectangle and we're going to rotate it about the line. And as we do so, from 1 to 2 to 3, we get a cylinder. Okay? And this is what we call a solid of revolution. Where you take a 2D figure, you rotate it about a line, and you figure out what three-dimensional figure you get. One way you can tell, one thing that I like to do, that I find helpful, is I mimic the shape the best that I can on the other side. So I mimic the rectangle on the other side of that line. Then I take the opposite corners because I'm rotating it in a circle, right? I'm going in a circle. So I connect the opposite corners with a circle, like so. I do the same thing on the bottom. I connect the opposite corners with a circle. And you can kind of see when you do that, you get a cylinder. It's a sloppy looking cylinder, but it's a cylinder. A little thing to remember, whenever you are rotating a rectangle, it's always going to result in a cylinder as your three-dimensional figure. Same thing with squares. When you rotate a square about a line, it's always going to result in a cylinder. Because think about what a curvy rectangle, three-dimensional rectangle is, right? The middle of a cylinder kind of looks like a rectangle with circles on top. Okay, so kind of think about it in that way. Okay. So we take a look at some more examples. Again, if we take a look at example 2, we're trying to figure out what three-dimensional figure this triangle makes when we rotate it about that line. Well, I'm going to mimic the triangle on the other side. Then I'm going to connect the opposite ends with a circle. And it looks like to me is that we got a cone. Again, if you visualize it too, think, what's a three-dimensional triangle that has a circle on the bottom? A cone. Cone is kind of like a three-dimensional triangle with a circle on the bottom. If we take a look at the next one, bear with my drawing here. I'm going to cheat a little bit. I'm going to mimic that shape over on the other side. And we're going to there's not really corners on circles, but we're going to kind of connect the opposite ends of the circle together with another circle. So I'm going to connect this part with a circle. Again, bear with my drawing. And then I'm going to connect this part with a circle. Same thing on the bottom. And I'm going to connect this part with a circle. It's kind of sloppy. But to me, this kind of looks like a donut or an inner tube. Okay, this is probably one of the harder ones you'll have to do. But you can say donut or tube. Something long, or donut. Use donut. I like donut. You can call it a donut. I don't really know. I don't think there's a super mathematical word for it, but donut is okay with me. You'll probably get more one like cone or rectangle, but this is a fun one to do. It's a donut. If we take a look at the last one, we have a rectangle. And we said whenever we rotate a rectangle, it's always going to create a cylinder. But what's a little bit different about this one is that it's not touching the line. So there's going to be something special about this cylinder. So I'm going to cheat and trace. That's somewhat accurate. So you're going to mimic this rectangle on the other side. And you're going to connect the opposite corners with a circle. So I'm going to connect this circle and this corner and this corner with a circle. Then I'm going to connect the top and bottom corners with a circle. I'm going to do the same thing on the other side. Connect these two together with a circle. Connect these two together with a circle. And we still get a cylinder, but we get a hollow cylinder. We get a cylinder with a hole in it, which you can call a tube. Tube or a cylinder with a hole in it. I'm not too super picky about that one. The really, really important ones you need to remember. And a lot of on your test, on your quiz, and things like that, these are more going to be multiple choice questions, so you just kind of have to be given the 2D figure and be able to figure out from your options what the three-dimensional figure is. But whenever you have a triangle, triangles are always going to result in cones. Rectangles are always going to result in cylinders. Half circles are always going to result in spheres. Okay? Those are kind of the three big ones you need to remember. In this third example, we want to know what 3D figure is created when rotating the triangle around side AC. If you remember that fact for rotating a triangle about a line, okay, we said triangles always create cones when we rotate them. So the answer is cone if you can remember that fact. If you don't remember that fact, even though it's in the coordinate plane, do what we did on the other problems. Mimic that triangle the best you can on the other side. Then connect the opposite corners with a circle. Now, it's a really bad circle. Oh boy, another bad circle. There we go. And it looks like a triangle with a circle on the bottom, which is a cone. So your answer is cone. There you go. Go ahead and try these practice problems. There's a key on Canvas if you need to check your answers. If you need to, watch the video again. The video is also on Canvas. But there you go.